So, in today's lesson, we're going to talk about volume. We're going to talk about volume of prisms and cylinders. We're going to get into cones, and we're going to get into spheres as well. And then we're going to talk about surface area and volume of composite figures. So let's get started. So the volume of a 3D figure is a number of non-overlapping unit cubes of a given size that will exactly fill the interior. What? Put simply, volume is how much cubic space a figure will hold. Think about a cup. You fill it up with water. That amount of water is the volume of that cup, okay? It's usually in cubic units. Volume of a prism. The volume of a prism, we already know what a prism is, with a base area, which we're going to call B, and a height h is equal to, so here's the formula, the volume is equal to the area of the base times the height. So in this depiction, we have a triangular prism. You would get the volume of one of the bases. So this one triangle, you would get the volume of, you would get the area of, and then you would multiply the area of this triangle by the height of the prism. And that's going to give you your volume. Okay, that's it. The area of a base times the height of the prism. If we have a rectangular prism, this is easy. It's just length times width times height. Because remember, the area of your base is length times width. And then you're going to multiply by the height, just like it says here. Another variation is a cube. Same idea. All of these sides are the same. The length, the width, and the height, they're all the same. So if I take my length and width, they're the same number. We're going to call it S. And we multiply it by the height. Because it's a cube, the height is the same as the length and the same as the width. It's just S cubed. Or again, the volume equals the area of the base times the height. So let's look at this one. Find the volume of the prism. Round to the nearest tenth if necessary. Completely unnecessary. So let's do this. Again, it is a rectangular prism. Go back and see what we're supposed to do. Length times width times height. The area of the base. Well, the area of the base is 13 times 3, which is 39. And then the height is 5. So 39 times 5, which gives you 195. So the volume of this rectangular prism is 195 centimeters cubed. Okay, you need to make sure that your units are cubed because we're talking about volume. This one says find the volume of a cube with edge length 15 inches. Remember, the edge is just what one of the sides of one of the faces is. Well, we know if it's a cube, all the sides are the same, so I'm literally going to be multiplying 15 times 15 times 15, which is 15 cubed. And that gives me 3,375 inches cubed. A swimming pool is a rectangular prism. Estimate the volume of water in the pool. What is the volume of water in the pool? So try this out on your own. Pause the video and work this out. Okay. So again, length times width times height. You should have multiplied 9 times 15 times 25, which would have given you 3,375 feet cubed. Now it says estimate the volume if the height were doubled. Estimate the volume if the height were doubled. So if I have whatever this is, that's 120 times 8 times 60. what would happen to the volume? Well, let's compare the two. If I have 120 times 8 times 60, right? Those were when I had 120 times 8 times 60. I get 5,000 or 57,600, and I believe it was feet cubed. Well, if I go back and I look at the height was 8, right? Here's the height of 8. I'm going to double that. It says estimate the volume if the height were doubled. What do you think happens if the height's doubled? What do you think happens if the height is doubled? Well, if the height's doubled, guess what's going to happen? I'm literally just multiplying this by 2, which means I'm multiplying this by 2. So the volume gets doubled, and I get 115,200 feet cubed. Now, why is that? Well, think about it. It doesn't matter what order you multiply in, right? So if I did 2 times 8 and then multiplied times 120 times 60, does it matter what order I multiply? No. So I could have multiplied 2 times 8 first and then multiplied by 120 or 60, or I could have multiplied 8 times 120, then 60, and then multiplied by 2. So in this case, it's okay that I multiplied 120 times 8 times 60 and then doubled that volume to get my answer, okay? Because it doesn't matter what order you multiply in. And again, 115,200 feet cubed. Now let's look at cylinders. So to find the volume of a cylinder, you're doing the same thing. You're getting the area of the base and multiplying it by the height. But remember, the base of a cylinder is a circle. So instead of just calling it the area of the base, because it's a circle, this never changes. It's always going to be pi times the radius squared. And then you're going to multiply by the height. Okay, so you're going to get the area of the circle and multiply by the height. So let's look at an example. And by the way, when you see pictures like this, when we're talking about the height, we're talking about the perpendicular height, as in the height has to be perpendicular to the ground. So when they do this, they're talking about the height that makes a right angle with the ground. So find the volume of a cylinder, give your answers in terms of, this should say pi. I don't know why it came out this way. Pi and round it to the nearest tenth. So first thing I need to do is I need to figure out what my radius is. Well, if the diameter is 18, then my radius is 9. Okay. So pi times the radius squared times the height. And I know the height is 14. So after I've already figured that out, I plug in and I do pi times 9 squared times 14. Don't know why it came out that way, so let's do this. I know the radius is 9, and I know the height is 14, right? Yep. And I know the radius is 9 because it was 18 divided by 2, because 18 was the diameter. So now all I have to do is plug in the volume equals pi times the radius squared times the height. So if I plug in, this now becomes the volume equals 9 squared times 14 times pi. And 9 squared is 81. And 81 times 14. Oops. 81 times 14 pi. So my volume becomes 1,134 pi. And my units were, I believe, in inches, so it's inches cubed. This becomes my answer. Okay? These are really easy. Remember, as long as you have the formulas, all you're doing is plugging in what the variables stand for. Well, I know r is radius and I know h is height. And I'm leaving it in terms of pi. So I don't need to change that. All right. So here we go. Find the volume of a cylinder with a diameter of 16 inches and a height of 17 inches. So let's do that. We know that the diameter is 16 inches, which means the radius is 8 inches, and the height is 17 inches. And we know the volume is pi times the radius squared times the height. We plug in, we get 8 squared times 17. Oops, I should say pi times pi. So the volume now becomes 64 times 17 times pi, which becomes 1,088 pi inches cubed. Ooh, here's a good one. The radius and height of the cylinder are multiplied by 2/3. Describe the effect on the volume. Describe the effect on the volume. This is, before we do anything, I want to remind you, scale factor. If the height and the radius are multiplied by 2/3, that means that you are using a scale factor of 2/3. And now we're talking about volume. So let's see what happens here. I have my first cylinder. I've got 24. Is that the diameter? No, it's radius. 24 and 33, they're both in inches. Okay, I'm going to multiply by a scale factor of 2/3, which gives me a smaller cylinder. That's 24. 24 divided by 3 is 8, times 2 is 16, so I get 16 inches. 33 divided by 3 is 11, times 2 is 22 inches. So let's look at the volume here. Well, the volume of the original one, remember, volume equals pi times the radius squared times the height. In this case, the radius is 24, and the height is 33. So if I plug this in, I get 24 squared times 33 pi, which gives me 19,008 pi inches cubed. I do the same thing here. Volume equals pi times the radius squared times the height. Oops. My radius now is 16. My height is now 22. So then my volume equals 16 squared times 22 times pi. So my volume now becomes 5,632 pi inches cubed. So what happened? Well, it's just like when we compared sides with scale factors a couple units ago, right? What happens? Well, to know what happens, we're going to have to make a ratio. And to make that ratio, we have to take, I'm trying to figure out how I went from 19,008 pi to 5,632 pi. What is the ratio that takes me straight from here to here? Well, to figure that out, I need to divide. Let's call this volume 1 and volume 2. I need to divide volume 2 by volume 1 to know what I have to multiply by to get 5,632 pi. I need to divide 5,632 pi by 19,008 pi. So let's do that. Let's go with, I'm still trying to figure out what some of these things do. What does this do? That's not right. Okay. So again, we're going from a volume of 19,008 pi inches cubed, and we're trying to figure out what we're multiplying that by, or what the scale factor is, to get a volume of 5,632 pi inches cubed. So remember, if we're going from A to B, we have to divide B by A. So let's do that. We're going to take 5,632 pi, put it over 19,000. Why did that come out that way? Oh, weird. There we go. 19,008 pi. Well, here's the beauty of using pi in both of these. They cancel each other out. Pi divided by pi is just 1, so these cancel out. And then 5,632 and 19,008 are both divisible by the same thing. They're both divisible by the same thing. They're both going to be divisible by 704. So if I reduce this, I could keep reducing this by 2. It's going to be very annoying to do so, but they're both divisible by 704. If I divide this by 704, and I divide the denominator by 704, I'm going to get 8 over 27. So that is my ratio. That is what I would have to multiply 19,008 pi by to get 5,632 pi. How did I go from 2/3? Because remember, in the beginning of this, I went from 2/3 of the height and the radius, and that fraction turned into 8 over 27. We're going to have to take a blast from the past right here. Remember, scale factor is equal to the scale factor of the perimeter. Scale factor of the area, however, is equal to the scale factor squared. This is units. This is area is always in units squared. Well, now we're talking about the scale factor of the volume. Well, the scale factor of the volume, or any volume, is always in units cubed. So guess what I'm going to do with that scale factor? I'm going to cube it. Well, 2 cubed is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 3 cubed, 3 times 3 is 9, times 3 is 27. So guess where this came from? It was literally the scale factor cubed. Okay? So instead of doing all the math and going through the process again, all I had to do was understand to answer this question. Because remember, it says describe the effect on the volume. I didn't have to get both volumes. I didn't have to divide 5,632 pi by 19,008 pi. All I had to do, if I knew this relationship right here, that the scale factor of the volume is equal to the scale factor cubed, all I had to do was take 2/3 and cube it. And I would know that if I took 2/3 of the height and the radius, then the new volume would be 8/27 of the original volume. That's all I would have to do. I wouldn't have to do all this work right here that I did and whatever I did on the previous page. One quick cube. All right. So we did all this. Now we're going to talk about cones. So the volume of a cone is exactly the same thing as the volume of a cylinder. The only difference is the volume of a cone that has the same height and radius as a cylinder is going to be 1/3 of the volume of the cylinder. Okay? So it's the same thing. Remember, the volume of a cylinder is equal to pi times the radius squared times the height. Well, the volume of a cone is still pi times the radius squared times the height, except it's 1/3 of it, which means that you can fit 3 cones that have the same radius and height as a cylinder inside of that cylinder. If I took one of those cone cups and I had a cylinder and they had the same radius or diameter and the same height, okay, so the height's the same and the radius is the same, I can fit 3 of these inside. If I filled this up with water and I poured it into this cylinder, I would have to take 3 of these cones worth of water to fill this up completely. Try it. I don't know where you're going to find all that, but good luck. All right. So let's do some volume of cones. Find the volume of a cone with radius 7 centimeters and height 15 centimeters. Easy enough. Gives me the radius and gives me the height. We're going to do this in terms of pi. So if I know that it's 1/3 times pi times the radius squared, radius is 7, height is 15. Plug it in. 7 squared is 49 times 15 times 1/3. Well, 1/3 of 15 is 5. 5 times 49 gives me 245 pi. Okay, so my answer is 245 pi centimeters cubed. Don't worry about converting it. Okay, 245 pi centimeters cubed. Find the volume of this cone. So the height of this cone is 8, and the diameter this time is 18. What am I supposed to do? Pause this and solve. So remember, because the diameter is 18, that means the radius is 9. They give you the height, which is 8. So now you just take your formula. You plug in 9 for your radius and 8 for your height. 9 squared is 81. 81 times 8 times 1/3. Well, 1/3 of 81 is 27. And 27 times 8 gives you 216 pi. 216 pi meters cubed. And finally, let's talk about spheres in terms of our shapes. Remember, we already looked at this. The sphere is a 3D circle. Radius of a sphere connects the center of the sphere, which is right here, to any point on the sphere. It could go here, go from the center to here, go from the center to here, go from the center to here, center to here. It doesn't matter as long as it touches somewhere on this green circle, some point on this green circle, and goes to the center. Okay. Remember, the great circle is the circle, it's the cross-sectional circle that cuts the sphere in half, and a hemisphere is half of a circle. Okay. A hemisphere is half of a circle. So here's the volume. It's a little doozy. The volume of a sphere is 4/3 times pi times the radius cubed, because we're dealing with volume, so the radius is cubed. So again, we take our formula, find the volume of a sphere, give your answer in terms of pi. We know the diameter is 24, but we know our formula is 4/3 times pi times the radius cubed, so we need the radius, which means the radius is 12. Plug that in. 12 cubed gives me 1,728. 1,728 divided by 2 is 576. Sorry, divided by 3 is 576. Times 4 is 2,304 pi inches cubed. 2,304 pi inches cubed. All we did was plug into our formula. We took 12 as our radius, cubed it, and then took what that was, divided it by 3, multiplied by 4. You could have multiplied by 4 and divided by 3. It doesn't matter. Please ignore this. This should say 24 divided by 2 is 12, not 6. Apparently I had too much pi that day. Apologize. Find the diameter of a sphere with volume 36,000 pi centimeters squared. We're going to skip this because we're not doing cube roots right now. So don't worry about this. This would be a big challenge problem that I would give you if we had a little bit more time, but this is unnecessary. And maybe we'll revisit this when we do cube roots next semester. So find the volume of the hemisphere. So in this case, we're given 15 meters as our radius. So if I know that the volume of a sphere is equal to 4/3 times pi times the radius cubed, this is for a sphere, then the volume of a hemisphere is half of that, because remember, a hemisphere is half of a sphere. So if I do that, I multiply 1/2 by 4/3, and half of 4/3 is either 4/6, and you could do it that way, that's fine. But we know 4/6 is the same thing as 2/3. Okay, so this becomes the volume of a hemisphere. Or you could do all this, and after you solve it, just divide it by 2. Same deal. Okay, same deal. So 15 is my radius. So I take 2/3 times pi times 15 cubed. I do all my work. 15 cubed gives me 3,375. I divide it by 3, and I multiply it by 2, and I get 2250 pi meters cubed. Okay. Skip this one. Let's do this one. It says a sporting goods store sells exercise balls in 2 sizes. Standard, that has a 22-inch diameter, and jumbo, that has a 34-inch diameter. How many times as great is the volume of a jumbo ball as the volume of a standard ball? Well, there's 2 ways of doing this. We could solve all of this and do the 2 volumes, divide, or we can figure out our scale factor. Remember, all spheres are similar to each other. So if I have a sphere that has a radius of 22 versus one that has a radius of 34, well, how do I go from radius 1 to radius 2? I'm just going to do 34 over 22. 34 over 22, they're both divisible by 2. 34 divided by 2 is 17. 22 gives me 11. And then all I have to do is divide, or sorry, not divide. All I have to do now is cube. Because remember, this is my scale factor. So now I need the scale factor my volume, which means it's the scale factor cubed. So I take 17 over 11 and I cube it. And 17 cubed ends up giving me 4,913 over 11 cubed, which ends up giving me 1,331. And are these divisible by anything? Don't believe so, so you can leave your answer this way. Okay, you can leave your answer that way. This is how many times greater the volume of the jumbo ball is than the volume of the standard ball. If I estimated this is going to give me 3.6 blah blah blah, so it's about 3.7, but I want my answer to be more accurate, so we're going to go with 4,913 over 1331. And again, you could have done it by finding all the volumes, and then dividing.